Welcome to this presentation on data engineering, foundations, uses, and applications. Today, we'll explore one of the most critical fields in the data-driven world. Data engineering forms the foundation for everything from business intelligence and analytics to artificial intelligence and machine learning. Over the next few minutes, I'll walk you through what data engineering is, why it's essential, the key responsibilities of data engineers, and how it's applied across industries. By the end of this session, you'll have a solid understanding of the significant role data engineering plays in driving innovation and decision-making. Let's get started. Agenda. Before diving in, here's a quick overview of today's presentation. First, we'll define what data engineering is and why it's important. Then, we'll discuss the key responsibilities of a data engineer, what they do daily to ensure data systems run smoothly. We'll also cover use cases to show how data engineering supports real-world applications. Next, we'll explore the industries and scenarios where data engineering is applied. Finally, we'll wrap up with a summary of key points and open the floor to any questions. Let's move on to our first topic. What is data engineering? So, what is data engineering? Imagine a world where data is the lifeblood of organizations. It flows from countless sources, social media platforms, IoT devices, websites, and transactional systems. But raw data is often messy, inconsistent, and scattered. That's where data engineering comes in. Data engineering is the practice of designing, building, and maintaining systems that make raw data usable. It involves creating pipelines that extract data from sources, transform it into a clean, structured format, and load it into databases, data warehouses, or data lakes. These pipelines are often referred to as ETL or ELT processes: extract, transform, load, or sometimes extract, load, transform. By ensuring data is accessible and reliable, data engineers empower businesses to make informed decisions, optimize operations, and even train AI models. Think of data engineers as the architects and builders of the data ecosystem. Without them, all the fancy analytics dashboards and machine learning algorithms would be running on shaky ground. Key responsibilities of a data engineer. Now, let's dive into the key responsibilities of a data engineer. At the core, they are tasked with building data pipelines. These pipelines automate the flow of data from various sources, like APIs, IoT devices, or relational databases, to storage solutions like data lakes or warehouses. But it's not just about moving data. Data engineers ensure that the data is clean and reliable. Imagine trying to analyze sales data where half the records are missing timestamps or product IDs. It's nearly impossible to derive meaningful insights. That's why data engineers implement validations, error handling, and monitoring systems to catch and fix issues early. Another major responsibility is infrastructure management. Data engineers often work with cloud platforms like AWS, Azure, or Google Cloud to configure scalable and cost-effective storage solutions. They optimize these systems to handle massive datasets efficiently. Finally, data engineers continuously monitor and refine pipelines. For example, if a pipeline processing millions of records starts slowing down, it's the engineer's job to identify bottlenecks and make improvements. Their work ensures that data flows smoothly and remains ready for use at all times. Data engineering use cases. Let's talk about where data engineering makes a difference. One of the most common use cases is business intelligence. For example, companies use data engineering to create dashboards that track key metrics like revenue, customer retention, or supply chain efficiency. Without clean and reliable data pipelines feeding these dashboards, decision-making would be based on guesswork. Another critical area is machine learning and artificial intelligence. Training an AI model requires massive amounts of high-quality data. Data engineers build the pipelines that provide this data, ensuring models perform accurately. For instance, a recommendation system like those on Netflix or Spotify depends heavily on well-engineered data. Real-time applications are another exciting use case. Think of fraud detection in banking. When suspicious transactions occur, banks need to act immediately. Data engineering enables real-time data streaming so fraud detection systems can analyze transactions as they happen. And finally, there's compliance and governance. Organizations must adhere to regulations like GDPR or HIPAA, which require strict control over how data is stored and processed. Data engineers play a vital role in setting up systems that meet these requirements. Where is it applied? Data engineering is everywhere. In technology companies like Google, Amazon, and Netflix, data engineering powers everything from user analytics to personalized recommendations. For example, when you binge watch a series, Netflix's recommendation engine, supported by data engineering, suggests your next favorite show. In finance, data engineering supports fraud detection, risk management, and compliance. A good example is credit card companies that analyze millions of transactions daily to detect anomalies. Healthcare is another area where data engineering shines. Hospitals and research institutions use it to analyze patient data and accelerate clinical trials. For instance, during the COVID-19 pandemic, data pipelines played a crucial role in vaccine development and distribution. In retail, companies like Amazon and Walmart use data engineering to optimize inventory, track sales, and personalize marketing. Media and entertainment rely on it for content recommendations, while logistics companies use it for real-time tracking and route optimization. No matter the industry, data engineering helps organizations harness the power of their data to gain a competitive edge. In conclusion, data engineering is the backbone of data-driven innovation. It transforms messy, unstructured data into actionable insights. By building reliable pipelines, ensuring data quality, and managing scalable infrastructure, data engineers enable businesses to unlock the full potential of their data. Whether it's powering AI models, enabling real-time applications, or ensuring compliance, data engineering is at the heart of it all. As you consider your organization's data maturity, think about how robust data engineering practices can help overcome challenges and drive growth. Thank you for joining me on this exploration of data engineering. Let's move on to your questions or comments.